Hi everyone, and this is Sandeep. You are watching Samyans Academy, and in this session, we are going to discuss about Jee Mains 2024 question. One more shot. Hi everyone, and this is Sandeep. You are watching Samyans Academy, and in this session, we are going to discuss about Jee Mains 2024 previous questions from the chapter Classification of Elements and Periodicity in Properties. Let us start now. The correct order of the first ionization enthalpy is, so here given that boron, aluminium, gallium family. Okay, now you see this is a boron, aluminium, gallium, indium, thallium. There is no thallium. There is no indium. Here we have the thallium. Okay, but the down the group, what happens? Down the group, and size increases, ionization energy decreases. But yes, some exception cases are there. Here down the group, so from aluminium to thallium, the thallium ionization energy is greater than gallium and it is greater than aluminium. Why? Because due to poor shielding of D and F block electrons, and it has poor shielding effect, means nuclear attraction forces on the lost electron is more, so ionization energy is more. Compared to aluminium and gallium, gallium has lesser in size due to poor shielding effect of d electrons, and gallium has lesser in size than compared to the aluminium. Due to that, it has more ionization energy than gallium. And it is an exception case. You have to remember this. The answer is 4 here. Thallium, gallium, aluminium. Thallium has more ionization energy. This is exception case. Down the group size increases, ionization energy decreases. But due to poor shielding effect of D and F electron, this thallium has more ionization energy than gallium and it has more ionization energy than aluminium. Due to poor shielding effect of D electrons of the gallium, it has more ionization energy than aluminium. So the correct order is thallium has more ionization energy than gallium. So gallium has more ionization energy than aluminium. So these are the ionization energy values. Now you see here, thallium has a energy 589 kilojoule per mole. Next one, gallium. So gallium has the energy 579 and aluminium has the energy 577. Is it clear? In kilojoule per mole, these are the values of ionization energies. Okay, and move on to the next question. In the next question, the electron affinity values are -4. Here given beryllium to beryllium minus, nitrogen to nitrogen minus, oxygen to oxygen 2 minus, and sodium to sodium minus, and aluminum to aluminum minus. Choose the most appropriate answer from the options given below. Okay. Now, what is electron affinity? Electron affinity means the amount of energy is released when you add the electron to neutral gaseous atom is called as electron affinity. Okay. Those are having, so the atoms, when you add the suppose when you add the neutral electrons, when you add the electron to any atom, some atoms release the energy for them, and delta H value is negative and electron affinity values are positive. Okay, some atoms, when you add the electron, for that energy is required, so for them delta H value is positive, and in that case electron affinity values are. So among the following oxide of p block elements, number of oxides having amphoteric nature is. Okay, you have to find out the amphoteric nature oxides. Already you know that acidic oxides are which are having more number of oxidation acts as a acidic oxides. That means the oxide with more number of oxygen also we called as acidic oxide. And in these, what are the acidic oxides are? These are the acidic oxides: Cl2O7. Next one is N2O5, N2O5, and silica oxide, silicon. So these are the acidic oxides, right? These are acidic oxides. Okay, what is the nature of these oxides? Here, more number of oxygens and non-metal oxides are called as acidic oxides. And among these, the neutral oxides are. So here we have the neutral oxide, carbon monoxide and nitrous oxide, nitric oxide. Okay, these are the neutral oxides. Okay, and the remaining amphoteric oxides are. Next one, amphoteric oxides are here. Here amphoteric oxides are lead oxide, aluminum oxide, this is we called as alumina, and tin oxide. And these are the amphoteric oxide, they have dual nature. So and yeah, so what is that? Lead oxide, PbO2 and Al2O3 and tin oxide. Okay, and these are the amphoteric oxides. So in this, how many number of oxides are amphoteric in nature? So that is 3. So this is integer type question. You have to type here 3. Is it clear, everyone? Okay, move on to the next question. So these are the acidic oxides and neutral oxides and amphoteric oxide. Is it clear, everyone? Right? Now, the transition metal having highest third ionization enthalpy is, okay. So before knowing that, third ionization means removal of the third electron. Okay. So the first you have to write the electron configuration of the all the elements. Manganese atomic number is 25, right? So here this we can write as organic. Sorry, argon. This is argon 4s2 3d5, or you can write as 3d5 4s2. Okay, and iron number is manganese number is 25, that is 3d5 4s2. And yeah, iron number is 26, argon 3d6 4s2. And chromium number, that is 24, right? So this we can write argon 3d5 4s2. Vanadium, scandium, titanium, vanadium 23, argon 3d3 4s2. And these are the electron configuration of given elements, right? Given transition elements. In this, when you remove the 2 electrons, now you see this is 4s2, right? 4s2. When you remove the 2 electrons, the next so that is a first ionization, means first electron you have to remove. Say a second ionization means second electrons you have to remove. The first 2 electrons you have to remove from the s orbital. After that, you see here among the all the elements, right? When you remove the 4s2 configuration from 4s2, from when you remove the 2 electrons from the 4s subshell, the remaining configuration you observe. And after removal of 2 electrons from this will become argon 3d5 4s0, and this will become argon 3d6 4s0, and this will become argon 3d5. Yeah, after removal of 2 electron I am saying, right? So this will become argon 3d4 with 4h0. After removal of 2 electron from this will become 3d3 4h0. Now you see, among all the electron configuration, which one has off filled configuration? Manganese. Okay. To remove the next electron, that is the third electron, for off filled and full filled configuration, it is required more energy. It requires more energy for off filled configuration. Now you see, for third electron, manganese acquired the off electron configuration. D subshell has 5 electrons. This is off electron configuration. When you compare with the other elements, okay, we require more energy to remove the third electron from the 3d5, means 3d subshell. Why? Because it is off filled configuration. So answer is here manganese. Okay, is it clear, everyone? And move on to the next question. Question: given below are two statements. Statement 1, both metal and non-metal exist in p and d block elements. And statement 2 given here, non-metals have higher ionization enthalpy and higher electronegativity than the metals. Okay, so which one is right option here? Yes, you have to select. Now you see, in P block, there is metals and non-metals. Okay, metals and non-metals are exist in a P block. But in D block, metals are exist. Okay, metals are exist in D block. Here given that both metal and non-metal exist in P and D also. So this is not correct statement. This statement one is wrong. Okay, that means a D block has only metals, right? Now statement 2 given that non-metals have higher ionization enthalpy and higher electronegativity than the metals. Non-metals means yeah, non-metals means when you move from the left to right in the periodic table, so the metallic character decreases, non-metallic character increases. Okay, when you move from the left to right across the period. So non-metal character increases. Means while moving across the period, what happens? The size decreases. If size decreases, then ionization enthalpy and higher electronegativity values increases. Means ionization enthalpy, electronegativity values across the period increases. That means the given statement is correct. Okay, non-metals have higher ionization enthalpy and higher electronegativity than the metals, so the given statement is correct. So here statement 1 is not true, but statement 2 is true. So statement 1 is false, but statement 2 is true, and this question given in Mains 24. Next question: the correct sequence of electron gain enthalpy of the elements listed below are. So here given that argon, bromine, fluorine and sulfur. Already you know that among the all elements, and which group has more electronegativity, electron affinity values, that is seventh group elements, fluorine and chlorine, bromine. So here given that fluorine and bromine also there, and afterwards we have sulfur and argon. Already you know that noble gas electrons, noble gas elements are having zero enthalpy values. Means enthalpy values of the argons, and it is nearer to the zero. Means argon has less electron affinity gain enthalpy values as compared to the remaining elements. Okay, then argon has to come last. Argon has to come last. Then which one will come first? Yes. So C has the fluorine has more electron gain enthalpy. Next bromine will come. So after bromine, sulfur will come. After sulfur, argon will come. Okay. So in the given element, among all these element, fluorine has higher gain, higher electron gain enthalpy than compared to remaining elements. Okay. So why this fluorine being in seventh group, right? So fluorine, chlorine, bromine, oxygen, sulfur, and argon. Here it will come helium, neon, argon, and this is a zero group element. Okay, electron gain enthalpy of zero group elements are zero. Okay, remember like this. So fluorine, chlorine has more electron gain enthalpy than fluorine. After fluorine, bromine will come. Okay, now here sulfur will come. Next one, argon will come. So which option is matching here? Now you see, yes, fluorine has more. This is C, bromine B, and sulfur here given as D, and argon is A, CbDa. So which option is matching here? Answer 1 is matching. Is it clear, everyone? Okay, move on to the next question. Now you see, here given some order, right? So here given four elements like this: A dash, B dash, and C dash, and D dash. Okay, now you arrange the elements. This is the periodic table, it is across the period, and this is a down the group. Across the period, what happens? Size decreases. Down the group, size increases. Means which has more in size among given elements? Across the period, what happens? Size decreases. Yes. Down the group, what happens? Size increases. Okay, so here C has more in size compared to the A and BD, right? Next one, D will come. Okay, this is the first. Let us assume this is in the group. It is given in first series. It is a second series. Okay, then after C, which one will come? D will come. Okay, why? Because it is a second element in the group. Down the group, what happens? Size increases. Okay, compared to the A and B, D has more in size, right? So next one, which one will come? Across the period, what happened? Across the period, size decreases. Okay, in between A and B, so which one has less in size? B has lesser in size, A has more in size. Now next B will come. Sorry, next A has more size as compared to B dash. Okay, this is atomic size increasing order. So this is given here. Option A is correct also. Next, you see the option B, order of metallic character. Already you know that as the size increases, and atom can lose the electron very easily. If atom loses electrons, means that is electropositivity character. So because of this electropositivity character, the metallic character also increases. Yes, down the group, what happened? Size increases, metallic character also increases. Okay, and this given statement also correct. Okay, so next one, size of the element. The size of the element is nothing but atomic radii only. So atomic radii follows this order, but here given in the reverse order. So it is given in the random order. It's not correct, right? Next, order of ionic radii. Ionic radii also follows same order. So B plus, A plus, B plus, C plus. Okay, ionic radii also follows the atomic radii order only. So here C is not correct, but D is correct. So here option, which one is matching? Second option is matching. A, B, and D. Is it clear, everyone? Okay. Then move on to the next one. Given below are the two statements. One is labeled as assertion. Assertion given that there is a considerable increase in the covalent radius from nitrogen to phosphorus. However, from arsenic to bismuth, only a small increase in the covalent radius is observed. And also the given that reason covalent and ionic radii in particular oxidation state increases down the group. Okay, so in the light of above statements, you have to choose the correct option from this. Okay, this is assertion region type question. Now you see this question. There is a considerable increase in the covalent radius nitrogen to phosphorus. Yes, nitrogen to phosphorus radius increases. Okay, and there is so much gap between the nitrogen size to phosphorus size. Then here from arsenic to bismuth, what happens? The increase in the size is very less. Okay, small increase in covalent radius is observed. Why? Because due to lanthanide contraction and poor shielding of 4f electron, and bismuth has comparatively similar size with you see the elements nitrogen, phosphorus, arsenic, antimony, bismuth, right? So bismuth and antimony has similar in size. Comparatively, it has more in size, but the gap between the size value is very less. Okay, why? Because due to lanthanide contraction or poor shielding effect of 4f block elements. Okay, so this is correct. Assertion A is correct, but reason is not. I think reason is not correct. Why? Because reason it has to give you due to lanthanide contraction. There we can observe the small increase in the covalent radius. But here given that covalent and ionic radii in the particular oxidation state increases down the group. So that is not correct. Okay. And both are correct. I think reason also correct, but it is not the correct explanation for the given statement assertion A. And covalent and ionic radius in the particular state of particular group which is increases only. But for this group, it has to give lanthanide contraction or poor shielding effect of 4f block electrons, right? So it is not there here. But both are both statements, assertion, reason, both are true. But reason is not the correct explanation for assertion. Okay. So which one we can select your answer? Both A and R true, but R is not the correct explanation of A. So your option is 2, right? So move on to the next question. Given below are two statements, and given below are the two statements, right? So just you read this statement. Along the period, the chemical reactivity of the element gradually increases from group 1 to 18. And statement 2 given that the nature of oxides formed by the group 1 element is basic, while that of group 17 element is acidic. So is it correct? Along the period, so now you see the periodic table, and this is a periodic table. So from this is a left side, this is your left side. I think this is your left side, right? Left side. On the left side, when you move from left side to right side, okay, the left extreme elements and the right extreme elements, right extreme elements, so more reactivity in nature. Okay, is it clear, everyone? Left extreme elements, these elements are more reactive. Similarly, right extreme elements and this side elements. Okay, when it is moving like this, the right extreme elements shows more reactivity. So in between metals, the moderate reactivity is there. But it is given that in this statement, it is gradually increases from group 1 to group 18 is given, but it is not correct. So actually what happens here, in this periodic table, left extreme element shows vigorous reaction, more reaction. Okay, the reactivity of these elements are more as compared to the remaining elements. Similarly, when you move right extreme means except this zero group element, though you see the remaining element. Okay, right extreme, when you move right extreme, the reactivity order also increases. Okay, but it is not gradually increases, it is increases to decreases and decreases to again increases. But it is given statement is not correct. Okay, statement 1 is not correct. Okay, the nature of oxides formed with the group 1 element is basic, while that of group 17 elements is acidic. Yes. So Nature of oxides: sodium oxide, potassium oxide, lithium oxide, all are oxides are basic in nature. Why? Because when you dissolve the sodium oxide in the water, so you will get corresponding hydroxide. Okay, and these metal oxides we called as basic oxides. Why? Because when you dissolve in the water, it will form bases. Similarly, seventh group. This is seventh group, right? And this is the first group. For seventh group elements, when you move from the fluorine to fluorine, chlorine, bromine, iodine, so when you take the any oxide, seventh group oxides like that Cl2O7, and any oxides when you take, when you dissolve in the water, it will form the corresponding acids. Okay, the statement 2 is correct, right? Statement 2 is correct. Okay, group 1 element is basic while that of group 17 elements is acidic. So this is correct. So you have to select statement 1 is false and statement 2 is true. So your option 3 you have to select. Is it clear everyone? Okay, move on to the next question.